Hello everyone, my name is Francesca and today I will present my project for the course of Applied Deep Learning at the Technical University of Vienna. The aim of this project is to apply deep learning techniques while implementing an image classification model for weather phenomena. In recent researches, the VGG16 architecture was implemented for this specific task and applied to the so-called WEPED dataset, which includes 11 classes for weather phenomena. With this setup, an accuracy score of 92% was achieved on the test set. Inspired by this work, this project aims to reproduce the EfficientNet architecture, particularly the B0 version, which was specifically chosen for its reduced number of parameters and its better efficiency. To address the challenges of a limited and unbalanced dataset, I used data augmentation and oversampling techniques, which effectively tripled the dataset size. Additionally, I also introduced two new classes, Tornado and Aurora, expanding the dataset beyond the original classes of the WEPED dataset. Samples for these new categories were sourced using the Bing image downloader. The model was implemented using TensorFlow and Keras libraries, and I created a standalone module for the MobileNet inverted residual block, which is the core component of the architecture. I then used this component, setting the various values for the parameters to obtain the various layers of the model. Then random search was used for hyperparameter tuning, optimizing three parameters: learning rate, activation function, and optimizer. Some key insights from this project are that the EfficientNet B0 architecture enables experiments to be conducted efficiently on a CPU system, striking a balance between performance and efficiency. Using the Bing image downloader was an effective way to gather additional samples simply by keyword, but manual verification was necessary. Random search for hyperparameter tuning provided a useful method for finding the optimal hyperparameters, which resulted being the same, coherent with the reported values in the literature, but at the same time required considerable execution time. The results show training accuracy of 93%, a validation accuracy of 87%, and a test accuracy of 91%. Here it should be noted that the discrepancy between validation and test accuracy values could be a result of an error performed during the data split, which led the validation set to be smaller in size compared to the test set. For any future work on this model, this issue must be addressed. However, the final test accuracy is close to the value reported in the most recent scientific paper, showcasing the efficiency of the implemented model. Now let's look at the model into action via a small demo of the weather phenomenon classification web application. To conclude, this project provided valuable hands-on experience in implementing a state-of-the-art architecture and experimenting with deep learning techniques. Thank you very much for your attention.